Mr. LaBeouf here with some quadratic equations for the Algebra 1 students. This video is going to focus on uh, some simple situations where b and or c are 0. When we have a quadratic function, a can never be 0, otherwise it wouldn't be quadratic. The first special case we're going to consider is, what if b is 0 and c is 0? Well, that results in the quadratic equation ax squared equals 0. The quadratic function would simply be ax squared when we set that equal to 0 to try to find where the graph crosses the x-axis. We get that. Maybe the a is 1 and we have x squared equals 0. Or maybe the a is 3. Maybe the a is 1/3. And actually, a could be negative numbers here as well. No matter what the a is, the vertex of the function is going to sit at the origin. There's going to be a double root. X squared is 0. The only solution to that is x is 0. Generally, when we have x squared equals a number, we say that x is plus or minus the square root of that number. Well, the square root of 0 is 0, and the plus or minus doesn't give us two separate numbers because negative 0 is also 0. So we say that it's a double root so that the fundamental theorem of algebra can still apply, still hold, that the equation that has a degree of 2 has the two solutions. So that's the first situation. Very simple. These others, by the way, just divide through by 3 or divide through on both sides by 1/3, and you still have x squared equals 0. All of these have the vertex sitting at the origin. So that's where b and c are both 0. The next special case is where just b is 0, but c is something else. That gives us the function ax squared plus c. And if we set that equal to 0 to try to find the zeros of the function, we get ax squared plus c equals 0. Subtract c from each side and then divide each side by a, and we have x squared equals negative c over a. And of course, if x squared equals a number, x equals plus or minus the square root of that number. Now, you might look at this and say, hey, we've got the square root of a negative. Well, not necessarily. It depends on the signs of the c and the a. An algebraic expression with a minus sign in front of it is not necessarily negative. Let's look at a few specific examples. We'll first consider the function 3x squared plus 12. And notice that the b is 0, the c is 12. The quadratic equation that goes along with that function, 3x squared plus 12 equals 0. To solve that, we would subtract 12 from each side and then divide through by 3. And when we get that, we find that x squared is negative 4. Now, in this situation, that negative c over a that was in the square root sign earlier is in fact a negative number in this case. This equation has no real solutions. There is no value of x that you can square to get negative 4. So for the graph of this function, 3x squared plus 12, the graph will not cross the x-axis. To finish this, of course, we would say x equals plus or minus the square root of negative 4, but the square root of negative 4 is not a real number. On the other hand, over here, we're going to add 12 to each side first and get 3x squared equals 12. And then dividing through by 3, we get x squared equals 4. And that has two real solutions. This x could be either plus or minus the square root of 4. The x is either 2 or negative 2. The graph of this function, f of x equals x squared minus 12, will cross the x-axis at 2 and negative 2. And by the way, anytime I'm doing a video involving a function, and if we're going to be talking about its graph, you should have out another device that will allow you to go to desmos.com and look at the graph to confirm the things that we find algebraically, confirm them with the graph. And finally, we'll consider the case where only c is 0. That would give us the function f of x equals ax squared plus bx. And of course, since c is 0, we know immediately that the graph will cross the y-axis at 0. In other words, the graph will go through the origin. If the y-intercept is 0, that's the origin. And to solve this equation here, setting the function equal to 0 and solving, we're going to do two specific ones down here. But we can actually solve this equation by factoring out an x. And that leaves us x times ax plus b equals 0. Now, when two numbers multiply to 0, either one of them can be 0. So we've got x times the parentheses. This x could be 0. Also, this x here could be negative b over a. If we set ax plus b equal to 0 and solve for x, we get negative b over a. That number would cause this parentheses to be 0, and we have a true statement. So those would be the two zeros of that function. And by the way, the y-intercept is 0 because c is 0. And we see here that the x-intercept is also 0. If we put those two things together, the graph of this function goes through the origin. And that's an obvious thing. That if we go back for a second and look, if you put a 0 in here and here, you get a true statement. Because you'd have 0 plus 0 equaling 0. So the graph of this function obviously goes through the origin. But it's going to go through the x-axis at another place. Let's look at two specific examples. Let's look at a equals 3 and b equals negative 12. And then we'll look at a equals 3 and b equals 2. And in each case, still c is 0. Well, to solve this first one, we notice that each term has an x, so we can factor it out and get x times 3x minus 12 equals 0. We have two numbers multiplying to 0, so either one of them can be 0. This x could be 0, or this x here could be 4. The 3x minus 12, in order for that to be 0, the x would be 4. 3 times 4 minus 12 is 0. So x equals 0, x equals 4. Those are the two solutions to that equation. And that tells us that the graph of the associated function, the graph of y equals 3x squared minus 12x, is going to cross the x-axis at 0, which is the origin, and that's also the y-intercept. And it's also going to cross the x-axis at 4. The other one over here, once again, we can factor out an x and be left with 3x plus 2. Okay? But once again, anytime c is 0, the y-intercept and one of the x-intercepts is the origin. This x here can be 0 and give us a true statement. So 0 makes this a true statement, and one of the zeros of the function is 0. The other 0, of course, is whatever we get when we set 3x plus 2 equal to 0. If we set 3x plus 2 equal to 0, subtract 2 from each side and divide each side by 3, we get x equals negative 2/3. So if you look at the graph of the function y equals 3x squared plus 2x, you'll see that the graph crosses through the origin, which is on both the x and the y-axis, and it also passes through, on the x-axis, it also passes through negative 2/3. So a few simple quadratic equations for you to solve. Bye-bye for now.